Hello, this is David Ferguson with MLC CAD Systems, and I'd like to talk to you a little bit today about OptiRoughs, a toolpath we all know and love. But if you've ever written an OptiRough, you've probably seen something that looks like what you see on my screen right now. An awful lot of retracts, what I kind of jokingly refer to as a little bit of a pogo stick with your spindle. We're bouncing up and down quite a bit on this OptiRough. And this is a very simple, straightforward OptiRough. Some step downs, some step ups, pretty much standard fare for what you're asked to do with your OptiRoughs. A little bit about this part. This is an older part from Mastercam's Tech Exchange. So if you go on Mastercam's website, you could probably find this guy on there, download it, and play with it yourself. But this, again, very complex shape, using an OptiRough as I would. But that tool is simply bouncing up and down, a bit like a crazy person on a pogo stick. So we want to look to see what can we do with our linking parameters for an OptiRough to, get that to be just a little less chaotic. And that's kind of the only word I have for it. So what I'm going to do here on my screen is I'm going to go ahead and go into my parameters for that OptiRough. And specifically, I do want to look at my linking parameters page. There's lots of little good things in here to help out, not just OptiRoughs, but as we'll look into a little bit, your other 3D toolpaths, because they all, for the most part, have a very similar linking parameters page. And what this really is, this is all about my retract heights, my retract strategy, and my lead in and lead out values. And there's quite a bit going on here. So at first glance, this is a very dense page with a lot of information. I'm just going to go ahead and point out really kind of the key points where you can, get some of the extra travel out of your toolpath, maybe improve the runtime, the efficiency of that toolpath a little bit. And the very, very first thing I want to look at is my retract strategy. OptiRoughs give me 3 basic strategies for retracting. Again, this is uniform among most of the 3D high-speed toolpaths. So what I'm talking about here applies to hybrids and rasters and equal scallops and waterlines and all that kind of good stuff. So, it's sort of a blanket statement a little bit. So the first thing I'm looking at here is my retract type. And I've got 3 basic strategies I can do. And by default, this toolpath is simply doing a full vertical retract, which means every time that tool comes off a cut, which on an OptiRough is quite often, I am retracting to whatever value I have set for my clearance plane. And that is just a Z value, either an absolute or an incremental value, positive or negative, obviously, depending on, the way your part is set up. In this case, I have a standard issue, positive 2 inches, which again is causing that tool to retract to that height each and every time it has to reposition itself at the end of the cut for the next cut. And we want to do better than that. So what we're going to look at is how I like to program OptiRoughs. And I use OptiRoughs in my regular machining practice, and I use them on basically very complex positive molds, very large molds. So travel time is a concern for me. I like to keep the runtime down where I can. So this is how I set up OptiRoughs for myself. And again, may be applicable to kind of how you want to run them, but it's a good strategy overall. So the first thing I'm going to do is change my retract strategy from a full vertical retract to my preferred method, which is a minimum vertical retract. Instead of using then a clearance plane, although I will still see that value at both the very beginning and end of the operation, what I use with a minimum vertical retract or a minimum distance value is a part clearance value. So based on whatever drive or check surfaces I've selected for this toolpath, the part or the tool, the tool will reposition itself using those drive surfaces basically as avoidance regions. I don't want to move through the part. And I can set basically a buffer there, 150 thou is the default value, and that's plenty to basically allow that tool to move around safely. However, when I generate this toolpath, sort of with the default settings, what I start to see, again, is a much lower retract height. I'm not going up to those 2 inches, and I'm staying sort of clear of the part. But I am seeing those as rapid moves. And that does worry me a little bit. If you're familiar with the phrase dog leg, you know that sometimes when a CNC mill is rapiding diagonally, it sometimes kind of decides which way it's going to go up to it, kind of on its own. And that can sometimes, present you with a bad day in the shop. But of course, that only happens on rapid moves. What I can do with all of the linking parameters for the 3D high-speed toolpaths is I can choose to output all of those transition moves simply as a feed output. And of course, when my machine is feeding, I'm not going to perform a dogleg. So if I'm doing anything other than a full vertical retract, if I'm doing a minimum vertical or a minimum distance, I'm always going to do that as a feed rate. And in all the years I've used OptiRough and kind of used these basic settings, outputting as a feed rate, I have never once nicked or run into the part while transitioning from one cut to the next. So that also allows me to give an option if I'm feeling confident, I know that's going to be safe. And again, I can set that feed rate to kind of whatever output I need as far as how quick it needs to happen. I can start thinking about bringing that part clearance a little bit closer, and that is just sort of a matter of comfort. So instead of 150 thou, I'll go ahead and bring that down to about 75 thou. Again, just trying to cut a little bit of that distance out of there. And I'll go ahead and regenerate that and just kind of see what this looks like. You can see, yep, just bringing everything, again, just that little bit closer. Now, the other thing I can look at with an OptiRough to sort of shed some time, and I'm going to go ahead and get myself sort of zoomed in here on my entry, and if we can kind of see my entry motion, this is sort of this green area here. I am using advanced display to display my entry motions as green, so hopefully that's noticeable on your screen. I have two basic sort of entry motions, and this is again the same for all the 3D toolpaths. I've got a primary lead, well we tend to call it primary, and then I've got a secondary lead. And basically on the beginning of each cut, or each pass, I would perform whatever the secondary lead is set to, and then I do the primary, right? So secondary first, primary second on the entry to the cut. On the exit of the cut, I would do the primary, my immediate sort of move away from whatever surface I'm machining, and then I would perform the secondary, on the way out. So it's secondary, primary on the way in, primary, secondary on the way out. And basically, I have a choice to do that as any number of sort of either horizontal or vertical arcs at a sweep angle, at a ramp height, at the size of that arc. I can make that as big or as small as I need to. The question I'm usually asking myself is, do I really need that secondary lead in or lead out? And with OptiRoughs, depending, typically in this case, it's an outside strategy cut. So I'm outside the material kind of cutting into the side of it. I don't really know why I need that secondary lead at all. So I can literally just turn that all the way off, and I'm left with just a horizontal entry into my cut and a horizontal exit on the way out. Again, if I want to, I can also make that a vertical arc entry and exit. I can tighten up the size of that radius a little bit. I can shallow the sweep somewhat. I can have a slight linear motion with a distance value. So I'll go ahead and I'll just do, say, maybe 50 thou linear motion. I'll drop the sweep angle to say 60 degrees. And the radius, I don't need 75 thou. That's a pretty big arc. I'll go ahead and drop that down to 25. And I'll leave the ramp angle there at 10 degrees. So just trying to tighten that up overall. And regenerating that, this is what I then see. My arc entry, or my entry, again, is just now sort of a traditional sort of shallow arc. I don't see that large secondary sweep at the beginning of the toolpath, and I don't see it at the end, right? And again, I can do that the same for other toolpaths. I'm going to go ahead and take a look at a waterline toolpath here. And you can see I've got kind of that same thing going on right there on the entry. I've got a large vertical arc in, followed by a horizontal arc, and I just want to, again, kind of tighten that up. So I'm going to go into the linking parameters for that, and I can see, okay, yeah, I've got a horizontal arc, again, kind of those same default values the OptiRough had, as my primary, and a vertical arc as my secondary. Now, for a finishing toolpath, that secondary arc may not be a bad thing. I just really don't need it to be that big. So I'm just going to try to tighten all of this up just a little bit. So again, I'll leave the distance at 0 this time. I don't need my linear entry. But I'll drop the sweep angle again. I'm going to go to 60 degrees. I'll drop the arc radius to about 25 thou. And that's for my horizontal portion. So that's the direct contact to the cut. And then, of course, the move directly out of the cut. And then for my secondary lead, I'll leave that at vertical. But again, I'll just kind of tighten that up a little bit. Just drop that value down to about 25 thou. And then hopefully what I see when that regenerates, we might have to wait a second for this one. It's got a lot of passes. I just see that entry and exit just be that little bit smaller. And anytime I can find a chance to sort of shorten some of those travel times out of a part, Entry and exits are a good place. Retract heights are a good way to do it. Hopefully, I'm just increasing overall the efficiency of how that toolpath's going to work. And again, if I am concerned about dog legs or moving that tool in an awkward position, I can always do those sort of minimum vertical or minimum distance retracts as a feed rate. And I sort of remove that chance of a dog leg happening unexpectedly. Okay, so just a couple of tips on how to just maybe tighten up and look at that linking parameters page for 3D high-speed toolpaths, and hopefully maybe a slightly different way than you are now. So thank you very much.